Welcome in. I'm Aditya Deshmukh. Today we are digging into one of the most important and most underappreciated shifts in enterprise AI, the rise of small, open weight language models that you fine tune and run yourself. For the last few years, the story has been bigger is better. The largest frontier models accessed through someone else's cloud, built by the token. But that's no longer the only path. And for a huge slice of real business work, it may not even be the smartest one. Over the next few minutes, we'll unpack why small, private, domain-tuned models are quietly becoming the practical choice and how the economics, the technology, and the risk picture all line up behind them. Let's start with the whole argument on a single slide because it's surprisingly simple. The problem: general purpose large language models are powerful, but they're expensive at scale, they're unpredictable in their output, and they route your sensitive data through external clouds. The approach: take a best in class open weight model, fine tune it on your own domain, compress it, and run it privately with retrieval. And the outcome? Deterministic, domain expert AI at almost no marginal cost, where your data never leaves your walls and you actually own the model. Everything else in this episode is really just unpacking those three boxes. So, why is this suddenly possible now? Because the economics flipped. Open weight models have caught up to the frontier. Something like GLM 5.2 now rivals the best closed APIs, and you can host it yourself. Quantization shrinks these models by around 75%, so they run on modest, even on premise hardware. And once a model is deployed, the marginal cost of each additional call drops towards zero. You're no longer paying a toll on every token. The capability you rented last year, you can now own, tune, and run. The question for leaders has shifted from which AI vendor do we pick to which workloads should we just own outright. Now, why not just point a giant general purpose model at everything? Because for core repeatable workflows, a generic LLM has four real weaknesses. First, it's creative by design, so it hallucinates and drifts away from the strict formats operational systems need. Second, it creates privacy exposure the moment you send customer, supplier, or contract data to a public API. Third, its per token pricing is fine for a pilot but compounds into serious money at production volume. And fourth, it has no real domain intelligence. It's never seen your templates, your taxonomy, your proprietary data, so it approximates exactly where you need precision. None of these are deal breakers for every use case, but they add up fast for the everyday ones. Here's the recipe that fixes all four weaknesses, and it's just four steps. First, fine tune. You train an open weight model on your own examples, and it learns your formats and produces consistent schema bound output. Second, quantize. You compress the weights down to 4-bit, cutting memory by about 75% so it runs on affordable hardware. Third, RAG, retrieval augmented generation. You connect your knowledge bases so the model pulls the right facts for each query. Fine tuning gives you structure, retrieval gives you accuracy. And fourth, deployed entirely in your own environment, on-prem or in your cloud, so sensitive data never crosses your perimeter. Structure, accuracy, and portability. That's the whole synergy. Let's talk about the actual models you'd build on because this field moves fast. At the top, you've got GLM 5.2, a roughly 750 billion parameter model with a million token context window released in 2026 under an open MIT license. Then there's Qwen 3.5, which spans tiny laptop sized models all the way up. DeepSeek for heavy reasoning, Llama for long context and a broad ecosystem, and lightweight options like Gemma, Phi, and Mistral Small for edge and low latency work. The headline: most of these are MIT or Apache licensed, which means you're free to self-host and commercialize them. Open weights are no longer the budget option. They're sitting right at the frontier. So why own a small model instead of renting a large one? 6 reasons. 1. Your data stays home, which keeps your compliance posture intact. 2. Your economics become predictable, fixed infrastructure instead of a meter that ticks on every call. 3. You avoid vendor lock-in because you actually hold the weights, no surprise price hikes or deprecations dictating your roadmap. 4. The model is deterministic and fast, which is exactly what automation needs. 5. It develops true domain expertise. A 4 to 14 billion parameter model tuned on your data can beat a giant generalist at your specific task. And 6. You can iterate rapidly, adapting it in days, not months. Notice none of these are about raw intelligence, they're about fit, control, and cost. This is the point I really want to land. Most everyday workloads simply don't need a frontier model. Think about what enterprise AI actually does all day: extracting data, classifying and tagging, summarizing, routing, producing structured output, answering questions over documents. That work is narrow, repetitive, high volume, and well defined. It's a perfect fit for a small, tuned model. You reserve the big frontier models for what they're genuinely great at: open-ended research, novel multi-step reasoning, complex planning, ambiguous creative work, the rare high-stakes one-off. Match the tool to the task, and the majority of your day-to-day calls move to something far cheaper and far more reliable. And that brings us to cost, which is where this gets striking. Look at the effective price per million tokens. A frontier reasoning model lands around $10. Mid-tier frontier models, $4 to $6. A self-hosted fine-tuned small model, around 20 cents. That's roughly 20 to 50 times cheaper per token. Played out on a realistic high-volume workload, say 10 billion tokens a month, and a frontier API can run well over $1 million a year, while the self-hosted small model is in the tens of thousands, up to 95% lower. And just as important, it's a fixed cost, not a meter that ticks up with every single call. One honest caveat: these savings show up at volume, and Frontier AP is still win for low volume, open ended work. But for everyday automation, the math is hard to ignore. Now, is this just a coding trick, or does it generalize? It generalizes because the same fine tune, quantize, retrieve, deploy pattern works anywhere the work is document heavy, high volume, and privacy sensitive. In healthcare, that's clinical documentation, coding, and prior authorization analysis. In financial services, risk classification and compliance summaries. In retail, product attribute extraction and review intelligence. In supply chain, contract clause extraction and disruption handling. In consumer goods, demand signal interpretation. And in utilities, smart meter events and work orders. Different industries, same architecture, just pointed at different data. Let me make that concrete with a few examples because they all follow one clean pattern. Unstructured input goes in, a fine-tuned small model plus retrieval processes it, and structured output comes out. Clinical notes become medical billing codes with a confidence score. A procurement contract becomes a clean list of penalties, delivery, and renewal terms. A messy supplier description becomes structured taxonomy tags. Point of sale data becomes demand commentary your planners can actually use. A regulatory filing becomes a risk classification with an audit trail. And a free-form support ticket becomes a category, a priority, and a routing tag. Same shape every single time, and that repeatability is exactly what makes this so powerful. Now, this isn't just theory. Here's some proof. In a real fine-tuning benchmark, a small Quen model under a billion parameters well hit a mean absolute error of 0.04. That's near perfect. It was a 98% improvement over a Llama baseline on the same task in a model 75% smaller, running at zero cloud cost. Sit with that for a second. Smaller, tuned, and owned beat bigger, generic, and rented on accuracy and on cost at the same time. That's the entire thesis of this episode, captured in a single data point. If you decide to go down this road, a handful of principles separate the rollouts that work from the ones that stall. Build privacy first, so the model trains and runs on your own infrastructure end to end. Own the full stack: data, fine-tuning, quantization, retrieval, and interface as one system, not a pile of disconnected projects. Insist on measurement. Benchmark every model on real samples before you trust it. So you're working from numbers, not flashy demos. Stay hardware agnostic, so you're never locked into expensive clusters. Iterate quickly using lightweight tuning, and make sure it's built for regulated environments from day one. Get those 6 right, and the technology mostly takes care of itself. So here's the bottom line in 3 numbers. 100%. The model runs entirely in your environment, so sensitive data never leaves your servers. 0. No per token API fees for these targeted workloads. And infinity. One proven architecture you can point at virtually any workflow that has proprietary knowledge behind it. Put those together and you get something rare, high return with genuinely low risk. And realistically, you can go from proof of concept to production in a matter of weeks, not the 6 to 9 months it usually takes to stand up an AI team from scratch. So what does the path actually look like? It's refreshingly short. Week 1 is discovery. Pick one high value workflow and really understand the data behind it. Weeks 2 and 3, you pilot. Fine tune a candidate open weight model and benchmark it on your real samples. Weeks 4 and 5, you harden it. Add retrieval, quantize, wrap it in an interface or API, and deploy it in your environment. And then you scale, rolling the proven pattern out to new use cases and business units. The key is to start narrow, prove it with numbers, and expand from a win, not to try to boil the ocean on day one. So let's bring it home. The big takeaway is really a mindset shift. You don't need the biggest possible model for most of the work in front of you. For the narrow, high volume, privacy sensitive tasks that make up the bulk of enterprise AI, a small open weight model fine tuned on your domain and run on your own infrastructure is often more accurate, far cheaper, and completely under your control. So if you take three things away: small, open weight, and private by default, up to 95% lower cost at scale, and the smartest way in is to start with one workflow and prove it with real numbers. Own your AI, tune it to your domain, and let the results make the case. Thanks for listening. I'll see you in the next one.